My name is Prashant Swami.
I'm Stephanie DeVita.
And I'm Abigail Rockefeller. We are Team ME34 here to discuss our senior design project, Design of Robotic Assisted Surgery Simulated Use Device. Robotic Assisted Surgery, or RAS, is a minimally invasive alternative to traditional surgery. It leads to fewer complications, less visible scars, and a quicker recovery time. Medtronic, a prominent medical device company, has been advancing robotic surgery since the field's conception about 20 years ago.
Medtronic has tasked us to design a specialized device for internal, non-clinical use to collect feedback on the functionality of the RAS system.
An RAS system has 4 arms, one of which is equipped with a camera, and the remaining 3 can be outfitted with surgical tools. The exercises test essential skills required by RAS. These include proficiency with fourth arm control, camera movement, and dexterity. Fourth arm control refers to the use of all tool-bearing arms. Camera movement is the ability to navigate within the abdominal trainer with the endoscope, and dexterity refers to fine motor movements. Exercises also simulate specific surgical procedures such as suturing and knot tying and are designed to be repeatable for efficient testing and reusable to promote longevity of the device.
We designed a total of 5 exercises, including shape cutouts, knot tying, ring track, modified O'Connor test, and nonlinear cuts. These exercises were modeled into a single 3-dimensional base.
This design was selected from 5 prototypes that were presented to Medtronic. It was preferred due to its smaller size, its compactness, and its organic design.
The device is approximately 8 by 6.5 by 3 inches to fit within Medtronic's abdominal trainer, which simulates the human torso. The device is easily transportable, so it may be used to test different RAS systems as required.
Proficiency with cutting shears is tested in the shape cutout exercise. This task includes a notepad of cardstock with a shape drawn on each page. The user grabs one paper at a time, cuts out the specific shape, and then discards the cut shape into the designated area. This task can be reused until all of the notepad is used up. The number of times depends on how many are left in the stack. This task is easily reusable by replacing the notepad with a new one and discarding old shapes as necessary.
Knot tying requires the user to thread a piece of string through a pair of eye pins and perform a surgeon's knot. The task is reset by manually cutting and removing the surgical knots, and is reusable as long as suture string is readily available.
The ring track exercise was inspired by the children's developmental toy, the bead maze. Just as with the children's toy, the user maneuvers a bead, or in this case, a rubber O-ring, around a wire track, utilizing fine motor skills. Along the track, the user must move impedances or blockages out of the way using the fourth arm in order to continue moving the ring. Once the user brings the ring to the other side of the track, the only duty they have to reset it is to put the impedances back on. These tracks are interchangeable and vary in difficulty. The ring tracks are held in by magnets, making changeover quick and easy.
The modified O'Connor test is a variant of a commonly administered surgical dexterity test. In the original test, a surgeon must place small pins into a grid of holes to measure their fine motor skills. We modified this test to include fourth arm control by having the user draw pins from a filled compartment. The user must pull apart the 2 sides of a slit in order to reach in and grab a pin. The task is completed when the user places a pin in each hole and then removes all of the pins and returns them to their origin. Because of this, there is no reset time and it is completely reusable. This is a video of Medtronic using their Hugo RAS system to perform this task on the initial prototype. The synthetic skin was designed using a combination of silicone gel and nylon mesh. It both simulates the properties of skin and is resilient enough to endure multiple uses.
Nonlinear cuts simulate suturing. For this exercise, a piece of synthetic skin with pre-cut nonlinear lacerations is provided, set into the side of the device. Along these lines, dots have been placed which guide the user in the placement of their sutures. The user must accurately suture the nonlinear lines to close up the laceration. The task can be used multiple times up until the synthetic skin rips, in which case it can easily be replaced with a new piece. In order to reset this task, the user can simply cut the sutures.
Medtronic is currently using this device to test their Hugo RAS system, and will continue to use this device for future systems as well. Medtronic has submitted our design to be patented within the year.